Hello guys, today I'll be explaining the notes questions of chapter 1 in chemistry of the level TM. So let's start. Which of the following systems constitute steady state situations and which are at equilibrium? What do we mean by steady state? By steady state we mean it is not in a closed system, okay, but it has constant properties. All right, then when we're talking about equilibrium, it is in a closed system and it has constant properties. So that means if we're talking about a steady state situation or equilibrium, we are gonna see now. An unopened means it's in a closed system. Bottle of sparkling water, a bottle containing CO2 and water. Since it is in a closed system, we say that it is at equilibrium. All right. Now, the second one, a Bunsen lit with a constant blue flame. So when we light the Bunsen burner, it's gonna be exposed to the air, to the surroundings basically. So it's not in a closed system, okay? But it has constant properties. So since it is not in a closed system but has constant properties, so we say it is at steady state. So that's a CQD number 1 done. Now CQD number 2. What happens when a system reaches equilibrium? When a system reaches equilibrium, then the concentration of reactants and products are constant. All right, and when we're talking about equilibrium, it has to be in a closed system. Now remember, we said there's a difference between reaching equilibrium and recognizing equilibrium. So here they asked us for reaching equilibrium. When we reach equilibrium, then the concentration of reactants and products are constant and the forward rate will be equal to the backward rate. All right. However, if they asked us to recognize equilibrium, we would say it is the constancy in macroscopic properties. So that's CQD number 2 finished. Now we have CQD number 3. Predict what would happen to equilibrium concentrations of H2O and H2 gas, respectively, if the partial pressure of O2 increased by injecting more O2 into the reaction chamber at 273 degrees Celsius. Whenever we are talking about pressure, we have to first make sure that everything what we're talking about is gaseous. So here we have gas, gas, and gas. The total number of gases in the reactants is 1. So let me fix the 1. And the total number of gases in the products is 1.5. So which one has a bigger amount of gases? It's definitely the ones in the products. So if we're gonna increase the partial pressure of O2, okay, in the case of gases, what will happen? The partial pressure is increased, so to maintain equilibrium, a counteraction will happen in where the O2 will decrease the pressure. So if it's decreasing its pressure, it needs to give some of its pressure to something else, to the other side. So again, let's write it like this. Let's do the 4 steps. So first step, impose change, okay? Pressure of O2 increased. All right? Then step 2, according to Le Chatelier's principle. What is Le Chatelier's principle? That there is a counter action, but it is partially. So it's a partial counter action. Then step 3, this happens by, how will this counter action happen? It will be the total opposite of our imposed change, which is the pressure of O2 decreases, all right? And fourth, as a result what happens? For the pressure of O2 to decrease, it needs to give its pressure to the other side. So since it's in the products, it will give its pressure to the side with less pressure, with less gases. So here it's 1.5. So it will give its pressure to the one with one gas. So as a result, the concentration, it doesn't fit, I will write it here. As a result, the concentration of H2O increases, whereas the concentration of O2 and H2 decreases. All right? Now, is this a forward or a backward shift? We know that from reactants to products, it is forward or right shift. However, from products to reactants, it is backward or left shift. So here we're going from the products to the reactants. So this is a backward or a left shift. That was part A. Part B. After the equilibrium represented above is established, some pure SO2 gas is injected into the reaction vessel at a constant temperature. So our imposed change is that we are increasing the concentration of SO2 gas. The second step is according to Le Chatelier's principle. What will happen? A partial counteraction. Now, this happens by, how does this partial counteraction happen? It happens by the total opposite of what the imposed change is. So if the imposed change is the increase in concentration of SO2, this happens by what? Decreasing the concentration of SO2. So if we are decreasing the concentration of SO2, it will have to give some of its concentration to the opposite side, which is the reactants. So consequently, as a result, okay, the concentration of SO3 increases, whereas the concentration of SO2 and O2 will decrease. So we said if it's going from the products to the reactants, all right, we say this is a backward or left shift, okay? So then the concentration of SO2 decreases, but it doesn't decrease than the original, no. As we put more concentration of SO2, so definitely the final concentration, even if it decreases, it will be higher than the original one, all right? And for sure, SO3, the concentration of SO3 is gonna increase. So that was part B. So our answer is the amount, they're asking which of the following has a lower value. Definitely the amount of O2 in the reaction vessel. But why did we not choose the amount of SO2? Because remember when I said that even though we decrease the concentration of SO2, all right, it will still be higher than the original concentration. Whereas O2, we didn't put more concentration of O2, we didn't put more O2. So since SO2 is decreasing, then O2 will also decrease, so it will be less than the original, if this makes sense. So the amount of O2 in the reaction vessel is the only thing that gets lowered. We don't have anything to do with pressure for now, so we're not gonna do it. Now, the chromate and dichromate ions are set up in equilibrium as follows. We have, if it shifts backwards, the color will be yellow. If it shifts forwards, the color will be orange, okay? So what happens in each of the following cases? If we increase the concentration of H+, let us do it with the 4 steps. First step, okay, imposed change, which is the increase of concentration of H+. Second step, according to Le Chatelier's principle, there will be a partial counteraction, okay? Third step, this happens by, how will we partially counteract? We will take the total opposite of our imposed change, so it's gonna be a decrease in the concentration of H+, okay? And then finally, as a result, if we are gonna decrease the concentration of H+, so finally, as a result, if we are gonna decrease the concentration of H+, we will definitely need to give some of the concentration to the opposite side, so it will give concentration to the products here. So what happens? The equilibrium will shift from the reactants to the product, so it is a forward or a right shift. So it shifts to the right, okay? The color change, since it's shifting to the right from the reactants to the products, it's a forward reaction, the color change will be orange. And what happens to the concentration of Cr2O7, Cr2O7 2-, because it is in the products, okay? We gave it concentration, so its concentration will thereby increase. So that was it for the first one. Now for the second one, I'll do it quicker because it all became easier. Now if we're gonna increase the concentration of Cr0 2-, our impulse change is increasing the concentration of Cr0 2-, then according to Le Chatelier's principle, there will be a partial counteraction. So this happens by, how do we do this partial counteraction? We're going to do the total opposite of our impulse change. So we're going to decrease the concentration of Cr0 2-, okay? And then as a result, what will happen? Since we're decreasing the concentration here, we will have to give the concentration to the product. So we are giving from the reactants to the product. So the concentration of Cr2O7 2- will definitely increase, okay? Also the same, but H2O, look, H2O is liquid, so we don't have an increase in the concentration of a liquid. You have to pay attention. Is it liquid or solid? If it's liquid and solid, the concentration will not be affected, all right? Only if it's aqueous or gaseous. So definitely here the concentration of Cr2O7 2- will increase. So since the concentration of it increased, it's moving from the reactants to products. So it is a forward or a right shift. So the equilibrium shifts to the right. The color changes to orange. So here it's also right and orange. And then also the change to Cr2O7 2- will increase for the both of them. So the first and second, it's the same for the both of them. Now, if we're decreasing the concentration of 2H+, let's do the steps again. Impulse change. What is the impulse change? Is that we're decreasing concentration of H+. According to Le Chatelier's principle, there is a partial counter action, okay? Then this happens by, how do we partially counteract? We're going to do the total opposite of our impulse change, so we're going to increase the concentration of H+. So to increase the concentration of H+, all right, we're going to have to take from the opposite side. So we're going to have to take concentration from here. So now it's the product giving to the reactant. So it's a backward or left shift. So as a result, the concentration of Cr2O7 2- will decrease. So the equilibrium shifts to the left, the color change becomes yellow, okay, and then the change to Cr2O7 concentration decreases. Now, so if we're gonna add NaOH, all right, it's gonna be Na+ and OH-. So I think logically speaking, we can do the 2H+, it will go away with the H-. All right, so what is happening now? We are decreasing the concentration of H+. So for decreasing the concentration of H+, this is our impulse change, all right? According to Le Chatelier's principle, a counteraction, a partial counteraction will happen, okay? And that would be to increase. So this happens by increasing the concentration of H+. So as a result, the concentration of Cr2O7 minus decreases. Why? Because we're taking concentration from here. So the products are now giving to the reactants. So this is a backward or left reaction. So that means adding NaOH will shift the equilibrium to the left. The color will change to yellow, and this concentration will decrease. Now adding HCl, okay, it is H plus and Cl minus. It will increase the concentration of the 2H plus. So our imposed change is concentration H plus increases. According to Le Chatelier's principle, there will be a partial counteraction. All right. This happens by decreasing the concentration of H plus. So to decrease the concentration of H plus, we're going to have to give some of it to the products. So the reactants are giving to the products. It will shift forward or to the right. All right. So now our final answer is that the equilibrium shifts forward or to the right. The color change will become orange, and the concentration of Cr2O7 minus O72 minus will increase. So that was for part C. Now part D. Predict what will happen to the concentration of CO2 if some CaCO3 is added to the system. We said if we add the solids, if we do anything with solids or liquids, it will not affect equilibrium. So adding a solid to the system will not affect equilibrium. All right, so everything will remain as it is. So the equilibrium of concentration of CO2 stays constant, stays the same. Now E, predict what would happen to equilibrium concentrations of H2O and H2 gas respectively if the pressure in the reaction chamber at 273 degrees Celsius is increased by adding unreactive HE. Unreactive means an inert gas. It's not reacting. Okay, since it's not reacting, it's not gonna do a change. Since it does no change, the concentrations stay the same. Okay, now F. The equilibrium system represented below is contained in a sealed rigid vessel. All right, which of the following will decrease if the temperature of the mixture is raised? Look, here it is negative, so our reaction is exothermic. So let's rewrite it. It becomes 4HCl plus O2. We do the equilibrium sign, gives us 2H2O plus 2Cl2 plus, because it's negative, it's exothermic, it will end up in the products, plus 113. Here's 3 kilojoules per mole. Okay, so what happens if we decreased the temperature? All right, so we're gonna do imposed change is decreasing the temperature. It is exothermic. Okay, according to Le Chatelier's principle, there will be a partial counteraction. Okay, this happens by doing the total opposite. So we're gonna increase the temperature of our exothermic reaction. All right, to increase the temperature, we're gonna need to take the temperature from the reactants. So now the reactants are giving two products. So we say it is a forward or right shift. So as a result, because we increase the temperature of the exothermic, the concentrations and the temperature, so concentration of reactants plus the temperature of reactants will decrease. So they're telling us which of the following will decrease if the temperature of the mixture. They're telling us which of the following will decrease if the temperature of the mixture is raised. So first of all, we have an exothermic reaction. So let's write it with the heat. So it will be the heat is included in the product. Okay? Now, they're telling us if the temperature of the mixture is raised, so the temperature here is increased. This is our imposed change. Temperature of exothermic is increased. According to Le Chatelier's principle, there is a partial counteraction. So I'm going to write partial counteraction. How does this partial counteraction happen? It will happen by decreasing the temperature of our exothermic reaction. So to decrease the temperature, it will have to give to the reactants. So now the products are giving to the reactants. So it is a backward or left shift. So as a result, because it is shifting from the products to the reactants, so the products are giving to the reactants, okay, the concentration of reactants increases as well as their temperature. So they're telling us which of the following will decrease. Alright, so we said as a result the concentration of reactants increase, and then the concentration of products will decrease. So our products, they're asking for what will decrease. We need to see the concentration of our products. So definitely HCl, which is in the reactants, will increase. We're not going to take it. O2, which is in the reactants, will increase, so we're not going to take it. And then Cl2, which is in our products, we said the product's concentration will decrease, so we're gonna consider it. Then HCl, it's in our reactants, we're not gonna take it. And then O2, which is in our reactants, we're not gonna take it. So basically, what we need to choose is our products, either of our products or the both of them. Why? Because their concentration decreases. Now part G. Consider the following systems: 2SO2 gas, okay, plus O2, equilibrium to SO3. State the effect of adding a catalyst to the system. A catalyst doesn't change the position of equilibrium. However, we attain it faster. Meaning that everything stays constant, alright, and only the equilibrium position is attained faster. That's for part G. CQD number 5. So, consider the following reaction system. Fill in the blanks to predict the effect of the given changes. So here, they told us the imposed change is the removal of Fe3+, so the concentration of Fe3+ decreases. Okay? What happens, according to Le Chatelier's principle, there is a partial counteraction. Okay? Now, how does this partial counteraction happen? This happens by increasing the concentration of Fe3+. So, as a result, what happens, since the Fe is in the reactants and this is the product, it needs to gain concentration. So it will take concentration from our product, so the products are giving to our reactants. So it is a backward shift or to the left. So we say that the imposed change is the equilibrium shifts to the left. Now what happens to the concentration of FeCN2+, because we're giving from the product to the reactants and FeCN2+ is in the products, its concentration decreases. Now let's do the second one, which is the addition of SCN-. Our imposed change is increasing the concentration of SCN-. According to Le Chatelier's principle, there is a partial counteraction. How does this partial counteraction happen? This happens by doing the total opposite, so decreasing the concentration of SCN-, alright? And then, as a result, what happens? If we're gonna decrease the concentration of this one, we need to give it to the products. So what's happening? The reactants are giving to the products. So then, it is a forward shift or to the right. So the equilibrium shifts to the right or forward, and FeCN2+, the concentration will increase. Why? Because we are giving it more concentration from the reactants. CQD number 6. CQD number 6. They're telling us, fill in the table to determine the effect of increasing pressure on the given equilibrium systems. Okay, what do we do whenever we have a case like this? Alright, we're going to count the number of gases in the reactants and the number of gases in the product. So here we have 2 in the reactants, gives us 2 in the products. Here we have 3 in the reactants, gives us 2 in the products. And then here we have 2 in the reactants, gives us 4 in the products. So if we have an increase in pressure in the first one, because they are the same number of gases, the equilibrium is not affected, so the amount of product remains constant. Okay? For the second one, since the reactants have more than the products, so the reactants will give more to the products. Okay? So if the reactants are giving to the products, this is a forward or right shift, and the amount of products increases. Then, for the last one, because we have 2 reactants and 4 products, and the number of products is more than the reactants, so then the products will give to the reactants, and if the products are giving to the reactants, it is a backward or a left shift, and then the amount of products will then consequently decrease. So that is for CQD 6. CQD number 7. Use Le Chatelier's principle to predict the effect of an increase in temperature. So what's happening is an increase of temperature on the given equilibrium systems. Okay, if you notice here, we have the temperature in the product side. So if we're going to increase the temperature, this is what our imposed change, increase in temperature. Since it's in the products, it is exothermic. All right? So according to Le Chatelier's principle, there is a partial counteraction. All right? How does this happen? This happens by decreasing the temperature of our exothermic reaction. If we're going to decrease our temperature, it will have to give to the opposite side. So now the products are giving to our reactants. So as a result, okay, what happens? The concentration of the products decreases, and however the concentration of the reactants increases. Why? Because the products are giving to the reactants, and because products are giving to the reactants, we say this is a backward shift. So the equilibrium shifts backward and the concentration of products decreases. For the second one, we have our heat is in the reactant, so it is endothermic. If we're going to increase the temperature of the endothermic, so our imposed change is increasing temperature of endothermic. According to Le Chatelier's principle, there will be a partial counter action. Okay, how does this happen? This happens by doing the total opposite of our imposed change, which is decreasing the temperature of our endothermic reaction. So to decrease the temperature of our endothermic, we'll have to give to the opposite side. So the reactants will give to the products. We call this a forward shift. So as a result, the concentration of our products increases because the reactants are given to the products, and the concentration of the reactants decreases because, again, the reactants are given to the products. So the equilibrium shifts forward and the concentration of our product increases. So now the last one here that we have is delta H is negative. Anytime we have delta H is less than 0, we know it is exothermic. Anytime we have delta H greater than 0, we know it is endothermic. So in this case, we have the heat in our products. So if we're going to write the equation in the term of heat in our products, it will be CO plus H2O equilibrium CO2 plus H2 plus 27.6 kilojoules. So as we need to increase the temperature, so our imposed change is increase in temperature of exothermic reaction. According to Le Chatelier's principle, there is a partial counteraction. How does this happen? This happens by the opposite of our impulse change. So we have to decrease the temperature of our exothermic reaction. All right, to decrease the temperature of our exothermic reaction, our products will have to give our reactants. So if our products give our reactants, it is a backward shift. So as a result, the concentration of products decreases. Why? Because the products are giving to the reactants, and the concentration of reactants increases. Why? Because the reactants are taking from the products. So our answer here is a backward shift, and the concentration of the product will decrease. Now, CQD8. Use Le Chatelier's principle to predict the effect of the addition of a catalyst on the given equilibrium system and equilibrium concentrations. We said, if we add a catalyst, what will happen? The forward reaction and backward reaction rate speeds up. Okay? So, because they speed up, there will be a new path with a lower activation energy. Now, we said then this catalyst doesn't affect the position of equilibrium. However, it attains it faster. So they're asking what happens to the equilibrium concentrations of the products. Then the concentration of our products remain constant because there was no change. Now, CQD9. Use Le Chatelier's principle to predict the effect of the addition of an inert gas. Inert gas doesn't react, so no reaction. Since it doesn't react, there will be no change. There is no change. So then they're asking for the what are they asking? They're asking for the concentrations of our products. So then the concentration of our product remains constant. Now, CQD number 4. The yield can be defined as the amount of product formed by a reaction. How can we increase the yield of ammonia production? You can increase the yield of ammonia production in many ways, either by increasing the concentration of N2 and 3H2, or so increasing the concentration, or increasing the temperature, or increasing the pressure. Now let's explain each and every one of them. If we increase the concentration, if we're gonna go through the 4 steps, we will result in what? In an increase in the concentration in the NH3. Now I did a mistake here. Alright, don't be like me and rush into the question without reading anything. Here we have delta H is negative. Since it's negative, it's exothermic. So if we have an exothermic reaction and we need to increase the yield of our products, we need to decrease the temperature. So if we decrease the temperature, if we're going to follow the 4 steps, we will result in what? In taking concentration from our reactants. So in the end, the concentration of NH3 will increase. Now for the pressure, here we have 4 gases and here we have 2 gases. So definitely if we increase the pressure of the 4 gases, they will have to give to the one with less gases, so they will give to the ammonia, which is NH3, and then consequently the concentration of NH3 will increase. So that was CQD number 4. Now CQD number 14. Alright, so here we have to be very smart with our graphs. We have to see what they say. They told us the graph below showed the yield of product changes as pressure and temperature varies. They're telling us as the pressure varies, there's no change in yield of product. So that means what? The number, I will denote this as number of gases on reactants and products side are equal. So then we'll have to go here into our options and we'll have to cancel all of the ones that don't have equal amount of gases on reactants and product side. We're going to cancel A. We are going to cancel B. We're also gonna cancel C. We're gonna keep D, and we're gonna cancel E. So very funnily, we got our answer using the first graph. Our answer is D. So this is using the first graph how we found the answer. Now, let's say there was an extra option that had the same amount of gases on both sides. If they ever brought this, how are we supposed to know? We're supposed to look at the second graph. The second graph tells us that as the temperature increases, the yield of our product decreases. So that means what? It's an exothermic reaction. Alright? So we're saying as we increase the temperature, according to Le Chatelier's principle, we'll have to decrease it. And for it to decrease, we'll have to take from the products and give it to the reactants. So definitely the yield of products decreases. So definitely it is an exothermic. So we're going to cancel out everything that's not exothermic. So we cancel out B, we cancel out C, and we cancel out E. And now here, if we use this graph, we would be left with A and D. And how to know if it was A or D? We would look again at the first graph, and so then we would know that A is not our answer, and D is our answer. So that's for CQD number 15 and number 14 top. Now CQD number 15. Carbon dioxide and hydrogen gases react at 75 atmosphere and 250 degrees Celsius to produce methyl alcohol industrially. So here we go. The backward reaction is endothermic. So if the backward reaction is endothermic, what does it mean? That means CH3OH gives us CO plus 2H2. This is our backward reaction. It's endothermic. So we're going to have the heat with the CH. Here, we're going to have heat with the CH3OH. So by the forward reaction, it is exothermic, but they're telling us that the backward reaction is endothermic. Now write a source of hydrogen for this industrial process. One easy way to get hydrogen is hydrolysis, where we break water to get H2 and O2. So this is one easy way to get hydrogen. There's many other ways. Whatever you like to use it. I don't mind. Now, complete the table below using the words decrease, increases, or no change. So, if we increase the pressure, look, here we have 3 gases, and here we have 2 gases. So if we increase the temperature, what happens? The reactants is gonna give to the products. So since the reactants are giving to the products, it is a forward reaction, and then the concentration of our products will increase. So they're asking us, if we increase the reaction, what happens to the rate of the forward reaction? It increases. And what is the effect on equilibrium on the yield of CH3OH? Because CH3OH is in our products, we said the concentration of products increases, so consequently the yield of CH3OH increases. Now, we said it is exothermic, so let's rewrite it knowing it's exothermic. 2H2 gas CH3OH plus the heat. They're telling us what happens if we decrease the temperature. If we decrease our temperature, according to Le Chatelier's principle, a counteraction will happen. What's the counteraction? That we need to increase the heat. To increase the heat, what happens? We need to take heat from the reactants. So now the reactants are giving to the products. So since the reactants are giving to the products, it's a forward reaction. So the rate of forward reaction increases after decreasing the temperature. Since the rate of forward reaction increases, the reactants are giving to the products, and CH3OH is our product. So consequently, it will increase as well. So, alright. So we said that the reactants are gonna give to our products, yes? So it is a forward reaction. However, I don't really understand because I checked the answer key for this one. They said here for this one that the effect of the forward reaction decreases. So you can, if you do it my way, you will get that the effect of the rate of forward reaction increases. But if you did it their way, which I think both ways are correct, okay? But them, I think what they did was CH3OH plus heat, okay, will give us the whatever, all right? So they put what? They put the CH3OH in the reactants, all right? And they put the rest in the products. I think probably this sentence has something to do with it, all right? So if you did it my way, it's not wrong, all right? But if you want to do it their way, it will be like this. You're gonna have CH3OH plus heat, equilibrium, CO plus 2H2, okay? We are what? We are decreasing the heat, so according to the Chatelier's principle, it will increase as a counteraction. And so then, for it to increase, it has to take from the products in this case. So here the products are giving to our reactants. And so then the backward rate is increasing. So then consequently, the reactants are no longer giving to the product. So then I think this is why they said that decreasing the temperature will decrease the effect on the rate of the forward reaction. But however, in both cases, the effect on the equilibrium will be increased of the CH3OH. Now adding a catalyst. If you add the catalyst, what does it do? It increases the rate of the forward and the backward, so the effect on the rate of the forward reaction increases, but it has no effect on the yield of product, so we have no effect for this one. Now, CQD number 16. We have bromine and hydrogen gases react together in a reversible reaction. Hydrogen bromide is formed. The forward reaction is exothermic. So they're saying this reaction, which is our forward reaction, we will have heat in our products because exothermic means heat in our products. A gas syringe containing an equilibrium mixture of hydrogen bromine and hydrogen bromide gases was sealed. That means it is what? Closed. It's a closed system and heated to 300 degrees Celsius. So, we increased the heat. The equilibrium mixture was a pale brown color. Now, because we increased the heat, we are increasing the heat of the exothermic reaction. So then we will see in part C, all right? What will happen if we increase the temperature of the syringe. So now, what is meant by equilibrium? Equilibrium means that the concentration of reactants and products are constant and the forward reaction is equal to the backward reaction. This is meant by the term equilibrium. Now, as the syringe plunger was pressed while keeping the other unblocked, the pressure increased. It was shown that the position of equilibrium did not change. The color of the gaseous mixture turned darker brown. Now, if you go back here, we have one gas, two gases in the reactants and two gases in the products. So, why did the equilibrium system not change? Because we have equal amount of gases on both sides. All right, now suggest why gaseous mixture turned darker brown even though the position of the equilibrium did not change. So we are increasing the pressure, right? Remember, we said as we increase the pressure, the volume decreases. So since the volume decreases, they will have more effective collisions. All right, from chapter 8 we're taking this. They will have more effective collisions. All right. Now, due to the more effective collisions, the equilibrium did not change, okay? But the reactions would be more and the concentrations would increase as well. The equilibrium did not change. The equilibrium stays the same, all right? We're not changing the equilibrium. We changed one thing and there's no partial counteraction. Everything changed with it, okay? So we increase the pressure and we decrease the volume. There is no partial counteraction because there are equal amount of gases on both sides, but instead both of them will have an increase in their concentration, and so then directly we know that the bromine, the hydrogen bromide, the hydrogen and the bromine, which have like brown colors, will react more, and so then it will become a darker brown color. Now see, the temperature of the gas syringe was increased to 400 degrees Celsius. I, what happens to the position of the equilibrium when the temperature was increased from 250 to 400? We know that this is what? An exothermic reaction. So we have heat in our products. They're telling us that we increase the temperature. If we increase the temperature according to, this is our imposed change, temperature, exothermic increased. According to Le Chatelier's principle, there is a counteraction that is partial. Okay? Then how does this happen? This happens by the opposite of our imposed change, which is decreasing the temperature of our exothermic reaction. And so as a result, our products will be giving to our reactants, because they need to get rid of our temperature. They're going to give to the reactants. So then the concentration of products decreases and the concentration of reactants increases. And because it's products giving to reactants, it's a backward or a left shift. So they're telling us what happened to the position of equilibrium. It moves backward or shifts to the left. Okay. Now part 2, what happened to the rate of the forward reaction and the backward reaction when the temperature of the gas syringe was increased? So as the temperature of the gas syringe increases, the rate of the forward reaction increases, right? And the rate of the backward reaction also increases. Because as the temperature increases, they are more likely to bump into each other, and so the forward and the backward rate will happen quicker. So then, consequently, their rate will increase. Now that was CQD 16 done. Now finally, we have this exercise. They want us to write the equilibrium constant. The equilibrium constant, which we denote by KEQ, it is equal to the concentration of products to the power of their coefficient multiplied by concentration of product to power of coefficient over concentration of reactants to the power of their coefficient times reactants to the power of their coefficient. Now, of course, we have to pay attention. Is it solid and liquid? If it is solid and liquid, we do not consider them, okay? So, the first one, we have gas, 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 so we can take it. What are we going to do? We're going to do the concentration of NH3, we don't need to know the exact value, okay, to the power of the coefficient, which is 2. Then we're going to put it over, let me redo it. So here we're going to put concentration NH3 to the power of 2 over the concentration of H2 to the power of 3 and the concentration of N2 to the power of 1. So that's for part A. For part B, we have gas, gas, gas. So we do the concentration of SO2 to the power of 2 multiplied by the concentration of O2 to the power of 1 over the concentration of SO3 to the power of 2. Then here we have aqueous, aqueous, aqueous. So we're going to put the concentration of H plus to the power of 2 plus the concentration of CO3 2 minus to the power of 1. And then finally the concentration of H2CO3 to the power of 1. Then here we have gas, gas, gas. So the concentration of NO to the power of 2 over the concentration of O2 to the power of 1 and N2 to the power of 1. And then finally, we also have gas, gas, gas. So the concentration of H2 to the power of 2 multiplied by the concentration of O2 to the power of 1 over the concentration of H2O to the power of, which one? To the power of 2. So that is it for chapter 1. I hope you guys understood and have a wonderful day. If there's any question, please comment and I'll explain.